Now we come to actual chemical reactions, which would be represented by chemical equation. There are general reactions which we've talked about in the past. You have your endothermic reactions, which means they require energy. Notice that energy here is in this equation on the left side of the arrow. It means it's a reactant. You need energy to get this reaction to go. It's an uphill reaction. The second general type of reaction is an exothermic reaction, where heat, exo means out, so heat is lost or released. Notice that now the energy is written on the right side of the equation. It is a product. And then every reaction needs activation energy. It's needed for the reaction, but it's not part of the reaction. We have designations for solids would be S, liquids would be L. You see the S here for a solid there. G would be a gas, like over here oxygen is a gas. AQ would be for dissolved in water or aqueous. There are 5 types of chemical equations, and this is just an introduction, so I'm just going to mention them to you, and then we'll break down each one individually in another video. The 5 types are this. First, you have synthesis, and you see here the word SYN, that's Greek for together. Synthesis means you put something together, like element A plus element X gives you a new compound. It's a chemical reaction because it's new. It doesn't have to just be elements, however. Here's water and here's carbon dioxide, and they form carbonic acid. Point is, there's only one product. There's nothing else formed. Second type of reaction is the opposite of synthesis. It is decomposition. Decomposition means you have the compound and it breaks up into elements. It doesn't have to just be elements. It can break up into parts. Very important here, however. Notice there is no charge on this element and there's no charge on that element. This is not a cation. This is not an anion. However, here, A is a cation. X is an anion. This is not dissociation. Dissociation would take AX and split it into A plus and X minus, but that's not what you have here. Dissociation is a physical change. Decomposition is a chemical change. It's brand new. The elements change from cation to neutral, from anion to neutral. The third type of reaction is called single replacement. This is where we have electrochemistry, like batteries. Notice here you have AX plus B. Don't be scared by the letters. It's just A is a metal and B is a metal. Notice that B replaced A. A is no longer a cation. Here it's a cation, here it's neutral. So a chemical reaction took place where B replaced A, single replacement. The reason B replaced A is because B is more active, and we have a chart that we look at to see which is more active. You can also go the other way. You can have a nonmetal replacing a nonmetal. Here you have cation A and anion X, and then you have a neutral Y. Y replaces X, and you get AY as the new compound, and you get X as an element that's no longer an anion. It has no charge. So again, a chemical reaction took place where a nonmetal replaced a nonmetal. Why? Literally why? Y is more active than X, and we look on the table to see that. The fourth type of reaction is called a double displacement reaction. It's a double replacement, or you can also call it an ion exchange reaction. Here's basically what it is. You have compound AX, cation anion. You have compound BY, cation anion. And look how they all switch places. AY, BX. Both the metal and the nonmetal switch places. So you have a double. Both means double. They both switch places. Double displacement. How do you know it occurred? We look for a gas being released, bubbles. We look for a precipitate, which means a solid forms. And sometimes waters form. The last type of reaction, you have combustion reaction. You always have oxygen. When you're a kid, they told you when you have a fire drill, close the windows to decrease the oxygen. So you have a hydrocarbon plus oxygen, and look at the products. They're very, very common to us. Carbon dioxide and water.